if you know what a log is and what the question is, then these problems don't take long. So somebody tell me, when I ask you the log of 10 or 100 or 1,000, I'm asking you for what? What's the answer to a log problem? It's an exponent. That's all I'm asking you. So, who knows? Who knows the answer to the left one? Faith, you know? No? Maddie? You either know or you don't. Just say no or yes. No. Gavin?
No.
Anna?
No.
Isaac, get out of your book, Isaac. Diana? No. Hannah, get out of your book. What's the answer? Nothing. Eric?
3.
He says it's 3. Let's see if he's right. You ready? If you know it's an exponent, then you're supposed to know the base. If you don't see a base, it's base what? 10. Base 10. And it's an exponent. Here it goes. 10 to what power is 10? Plus 10 to what power is 1,000? 10 to the first is 10. 10 to the second is 100.
You said 2,000.
Oh, did I say 1,000?
Yeah.
I didn't mean 1,000. Sorry. 10 to what power is 100? 2. Okay. 1 plus 2? 3. Eric got it right. Good? You see what happened? I'm just asking for exponents. When I say log of this, it's an exponent. Log of this, it's an exponent. It's 1 plus 2 is 3. Next. John, what's the answer?
2.
He says the answer is 2. Let's check it out. Ready? This is base 10 because you don't see it. This is base 10 because you don't see it. So 10 to what power is 1,000? 10 to the third, right? Minus 1. 3 minus 1? 2. John, good job. Got it right. Log of, next one. Log of 10 squared is? Anybody can say this one? 2. Okay. Let's see. What? Okay. First of all, this is 10, and I want to know 10 to what power will be 10 to the second. It's kind of it's almost too easy, isn't it? It's like saying this. 10 to what power would be 10 to the second? It's got to be what? It's got to be 2. Okay. Now here's the deal. All of these problems I just did with you, you can do them a different way. The different way would be the properties. The properties say, or you don't have to do it this way. You can do it this way. Log plus log. Log plus log can turn into just one log. As long as you take the 10 and the 100 and do what to them? Multiply. What is 10 times 100? 1,000. Now answer the question. What's log base 10 of 1,000? Isn't it just 3? It's the same answer. So when you look at the properties, guys, it's going to say this to you. If you see log of a number plus log of a number, it can be converted back to just one log of the two numbers multiplied. So multiplication and addition go together. Okay? Or you can go the other way. You can say log of multiplication can be split into 2 logs. You can go the other way. Yeah, John?
The bases have to be the same, right?
Yes. God darn it, John. Good job. I didn't even say that. Your bases have to be the same to apply these properties. You have to keep the bases the same. Okay. What about this one? Yeah. Maddie, are you looking ahead, or did you already do this? You already did it. Okay. Log of a number minus log of another number is the same as 1 log, as long as you do what? Divide. Take 1,000, divide by what? 10. That's log of what? 100. Base 10. 10 to what power is 100? 2. It still works, right? Another property. Division goes with subtraction, or subtraction goes with division. They go together. Okay, next. This one's kind of weird. This power you see out here, if you're taking log of a number raised to a power, the power can actually go in front. So you could do this. 2 times log of just 10. And now you should know that log of 10 base 10 is what? yeah, log of 10, base 10 is 1. 2 times 1 is 2. Bingo, we got it. So these are your 3 properties you're going to see when I switch pages on you. And let's just go over them pretty quick because now you've seen them. Now it should make a little more sense to you. Okay, the first property is known as the product property, or just say multiplication. If you're taking the log of 2 numbers multiplied, it's the same as split 1 log into what? 2 logs. Log of m, the first number, plus log of n, the second number. That's it. If you see the quotient, meaning division, if you see division, you turn it into subtraction. It's log of m, take away, log of n, and there it is. And these are just properties we apply to just, manipulate the problem a little bit to make it easier for us. Last one is called the power property. If you're taking log of a number raised to a power, where can the power go? Out in front. And then we just say n times log of m. That's it. There's 3 properties. You got to use them all through this assignment. All right, here's some quick practice. Log of 20. Okay, what's log of 20? Well, log of 20, we can change log of 20 to log of what? 5 times 4. Because that is 20. Well, can you break that up? Multiplication breaks up into what? Addition. So you'd say, oh, log of 5 times 4 is the same as log of 5 plus log of 4. Okay, put 4 there. That's all it is. And this is what you're doing today. They're just pretty much laying it out for you. They're doing most of the work. Okay, what about this one? Log of x to the 9th, base 5. Do you see multiplication here? Do you see division here? I mean, I don't see this times this. I don't see this divided by this. So this one's going after this property, the power property. Where can the 9 go? Out in front. So you got a 9. That's it. Number 9, I guess. It says log of 24, take away log of 3. They're starting you with subtraction, so you should go from there to where? Division. So you'd say log of what over what?
24 over 3.
24 over 3. Yeah, the first number is the numerator, the second number is the denominator. That's how it goes. But that, you guys can simplify to be log of 8, base 2, right? Okay. Now, just a little hint. Every time you do a problem in your assignment today, if you do know the answer to this, continue. Like for instance, I don't know 10 to what power is 4. I don't know 10 to what power is 5. I don't know, so I just stop. That's my answer. But on this one, can you keep going? What's the answer to that? 3. It says right here, 2 to the 3rd power is 8. And that, if you can do it and keep going. All right? Because in the back of the book, you're going to look and go, where did they get that 3 from? Oh, they just answered this question. 2 to what power is 8? 3. Okay. Last one. Okay. Okay, you're taking the log of 5 times x to the 4th. So right away, you should be thinking, this is a multiplication problem. It should split into addition. So it'd be log of what? 5 is the first number, plus log of x to the 4th, the second number. But then they go another step further because they noticed, what they noticed? There's still another property we can apply. Power property, right here. The 4 can go where? In front. So we could put the 4 there. Can we do anything with log of 5 base 30? No, so we're done. This would be your answer today, right there. All you're doing is applying the properties. That's it. Okay, here we go. Now we're starting your assignment. It says write the expression as a what logarithm? Single. Meaning, when you're done, I only want 1 log on the paper. That's it. So what's this one going to be? Log, take away, log. Do we go back to multiply or do we go back to division? Division. Okay. So we're going to go log of base 4. 32 what? Divided by 2. Okay, which is what? 16 log of 16 base 4. Now we got it down to 1 log. It looks like we're done, right?
Equals 2.
Yeah, see, this is the problem. I always think if they tell me to get it to 1 log, why wouldn't I just leave it as 1 log? But if you know it, you should say the answer. What'd you say, Gavin? Gavin says it's 2. Is he right? 4 squared is 16. He's right. He's got it. If you can do it, do it. And if you can't, you just leave that as your answer. Keep going. Keep going. Don't wait for me. If you're waiting for me to get that answer for you, then you're not, oh, I don't know if you really get it. Try it. If I see addition, which I do in the middle, what should I do? Go to multiplication, exactly. Turn 2 logs into 1 log and then just multiply the 2 numbers, 5x times 3x, right? 15x squared is right. Log of base 3. No, I don't know why I put base 3, sorry. Base what? Base 4? Okay. Now, if you can answer it, answer it. 4 to what power is 15x squared? Can you answer that? No. No. You're done. Okay.
And what about power potency?
Power what?
Potency?
Property. Yeah, what? That was. Oh,
Yeah.
yeah, he wants the 2 to go out in front. You see that? Hang on. You would be right, Isaac, if it said this. Log of 15x, all of it raised to the second power.
Oh, okay.
You would be right. See, this 2 only goes with
Yeah.
the x. And for me to put the 2 out in front, you know what I'd have to do? I'd have to split it back into this again. I'd have to split it apart and go log of 15 plus log of x squared. And then now I'm doing the opposite. I want to go down to 1 log. I don't want to expand it back to 2. That's the only way for me to do what you want me to do. This, what he said is right, as long as you have that look. But you don't have that look. Did that help? Are you okay? Isaac, are you okay with what I just said? Yeah? Okay. Everybody okay? Okay, that's the answer right there. Last one, I think, or no, are there 2 more? 2 more, okay. So, what do you see in the middle? Plus, you see add. Add, you should be thinking what? Multiply. So you're going to do, oh, wait. Before you multiply, tell me what that 6 is. Isn't that the exponent right here?
Yeah.
So you could do that right away if you want. Okay? So now, you see addition, turn it into 1 log as long as you multiply. What are you going to multiply?
X and Y.
The x to the times the y base 2. Well, do you know the answer to this? 2 to what power would be all this? No, you're just done. Okay? Sometimes these go super quick. Like that would be a pretty quick one. Looking at the next one. Right off the bat, I would start with, what do you think I'm going to start with?
2.
Yeah, that 2. Let's get that 2 out of the front. Put it where? Above the 6. Okay, so it really says log of 6 squared, base 4. Now I'm looking going, oh, there's a subtraction sign here, so what am I going to do? Divide, turn it into division. This divided by what? What's on top?
Instead of saying x squared, can you just write 36?
Yes, I will. That's what I'm going to write next. So you'd write what?
6.
36 over
9.
9, which is 4. Answer? Do you know the answer to this?
256.
256. No.
Isn't it 1?
It's, yeah, it is. It's 4 to what power is 4? 1. Isaac, you did this. You took 4, you raised it to the 4th. That's not what a log is. A log says For your base, to what power is that number 4? 4 to the first is 4. Yeah? Can we move on? Okay, you guys went from 2 logs to what? 1 log, that's called a single log. Now take 1 log and do what? Expand it. Make it 2 logs, make it 3 logs, make it 4 logs. Whatever it happens, okay? Using your properties. So if you're looking at this one, what do you think the first thing you have to notice is? Yeah, it's division right here. You should be noticing this. It's a division kind of number. So I could take 1 log and turn it into 2 logs, as long as I what? Subtract. Okay? So what's the first number going to be? Log of?
X squared.
Yes. The numerator is the first number, and the denominator is the second number.
Can the 2 go in front this time?
Yeah. Then the next property I would apply is the power property. Put this up here.
Would you
Right?
put the 3 as a subscript next to it?
Oh, forgot my base, yep. Put the 2 here and be done, right? 2 times log of x base 3 minus log of y base 3. I put loy, it's not log. Okay, log of y base 3. And you don't know the answer to any of these. You don't know log of x base 3, you don't know log of y base 3, you can't go on. This is where you quit. You're just using the properties that were given to you, right? Okay. Colton, are you with me? Yeah. Eyes closed. Okay. Come on, guys, stay with me. Next, do it. I see multiplication. You're thinking what? Addition. Log plus log, right? Okay, first number? 9 base 3. Second number? X to the 5th base 3, right? The only thing I see is probably the power property. I could do this, right? Okay. Log 5 times log of x base 3. And then this one, what should I do?
You just turn it into a 2.
Yeah, you know the answer to this one. What's the log of 9 base 3? 2. 3 to the second is 9, so it's 2. If you know it, go ahead and give me the answer. If you don't know it, just leave it as log or whatever. Okay? Nobody's hand is going up in the air, so I'm thinking you guys are doing just fine, right? Okay, try these. C, try C. Okay. I'll download this as soon as I get done with this, okay? All right. Division, what are you gonna do? Subtract. Log minus log, right? First number is 125 base 5. Second number is? Second number? XY. Okay, right? Base 5. You see something?
5.
Oh, yeah, 5. Log of 125 base 5, you know the answer. What is it?
3.
3 minus, what about the next one? Can you split that up? It's multiply. Yeah, guys, this is log of 2 numbers multiply. You can split that up into what? 2 more logs. Log of x. What am I going to do in between them? Add. Multiply is addition. Okay, so now the answer becomes 3 minus this, right? Is this right?
You have to disprove
Yeah, see, here's the deal. You guys have to look at this closely. It said this minus whatever this is. Okay, did you see what I did? When you subtract the log of xy, you have to keep those grouping symbols around it. And when you keep them around it, then you take the minus sign and distribute it through. What's it turn this thing into? 3 minus, this is -1 times all of this. So what's this going to do to this one? It's going to make a negative. Base 5. Forgot my bases. What's this going to do to this one? It makes a negative. There you go. So that was a tricky one because it says subtract whatever log of xy is. You split xy into addition, but then you have to run the negative through to get this look. Good? All right. Go. Next one. Bunch of numbers being multiplied. What are you going to change it to? Addition, right?
Yep.
Log of what?
2 of
X squared plus log of what? Y squared plus log of what? Z to the -1. Ouch, I'm running out of room. Okay. But every one of those numbers you took the log of have powers. So I'd apply the power property, right? 2 log of x plus 2 log of y plus, yeah, it's going to be plus -1 log of z. Yeah, do I need to write plus -1? No, just write what? Minus log of z. Sorry, I had to crunch that one in there. You okay with that?
Do we have to write it like that way, or is it like,
Well, which way do you want to write it?
I mean, like log of x squared plus log of y squared?
Oh, you want to quit there?
Do we have to?
No, you do. You have to use all your properties, you know,
Okay.
so keep going. Anytime you see log of a number to the power, put the power up.
Okay.
Okay.
What about the base you just?
Oh, well, see, I didn't write the base this time. You know why?
It's 10.
Because it's 10. I never have to write 10 if I don't want to. If you want to write 10, go for it. It's up to you. Without a base, I know you're 10. Okay? If you don't put a base down, you're 10. That's called the common law. This one, keep going, see what you can do before I get there. What do you see in between the numbers? Log of, is that a multiplication problem or is that division?
Multiplication.
Yeah, 6 times, right? Okay, so you do log of 6, then what?
Plus
Plus log of parentheses, right? Do you know the answer to this? 4 to what power is 6? No, that one's done. The only thing you can do from here is when you take the log of this number, that 2 is a power, part of the power property, put it out in front. 2 log of what? 3x minus 1,
With a base of 4.
base of 4, thank you. There you go. Okay. Now, the change of base formula right here, I'm going to come back to that last. Would you go to the next page? There are 2 problems. You can do these in probably 1 minute, maybe 2. They want you to use your properties to do what? Evaluate. You know what evaluate means? Give me the answer. Is the answer 3, 4, 5, 6, 7? What's the answer? Use your properties when you look at that problem. What'd you do? Turned it into division, I hope. Yeah, 96 over what?
3,
3, but that's the same as not log of
2.
what? 32, yep. And now, because they're saying evaluate, that means you can get answers. You should be able to do it. Probably without your calculator. You need to know 2 to what power
5.
is 32? Well, it is right here, isn't it? It's a perfect fifth power. It comes from the 2. That's wrong. Sorry, don't look at that. Don't look at that. 2 to the what? 2 to the 5th is the answer, right? I should say 5 is the answer. Good? Last problem. Then we'll go backwards again. Okay. Addition in the middle. What are you going to do? Multiply. What's this? 36. 6 to what power? 2 seconds. There it is. One good thing about today, if you never knew that the log is asking you for the exponent, today you probably do because I keep asking you for this. That's what we're looking for, the exponent. Okay, these problems are just using properties to make it easier for you to get the answer, okay? Now go backwards and go to the bottom of this page. This would be like page 2, I think. Here's what they're asking you now. This is actually super easy, but pay attention because some students do get these wrong on the test. All right, it's change of base. We will be changing your base for a reason. You see this problem right here? 8, it says log of 32 base 8. If I ask you that question on a test, it's a hard problem. I'm asking you 8 to what power will give me 32? Well, you know 8 to the first is what? 8, not 32. You know 8 to the second is what? 64. You missed it, guys. But what you do know, the answer is between what? 1 and 2. Okay. It's what? This is a hard one. If you want to use your calculator, you're allowed to. Watch this. You don't know this answer? Then change the what? Change the base. How do you change the base? If you're ever asked log of a number, base b, all you got to do is just write log of m over log of the base. Do you guys know what base I changed it to?
10,
How'd you know it was 10?
because there wasn't a number underneath log.
Because there's no number. It's base 10. Now, next question. Do you know why I changed it to base 10? You ever seen this button on your calculator that says log? Guess what base it is? It's base 10. There's only one base that's been programmed into your calculator. It's base 10. So now that you have it, you can use it to find the log of any number. All right? You ready? What is log of 32 base 8? Don't know. Why don't I just change it over to what? Base 10. All I'd have to do is this, and it should work. But you gotta type it in.
1.6 repeating.
So Maddie said it is.
5.
What?
5.
It is 5/3. You know what? This is really 1 2/3, which is really 5/3. If you wanted the exact answer, that's it. If you want the approximation, that's it. And how do you know if you're right?
Check.
How do you check it though?
8 to the 1.6. It should get you roughly.
Yeah. Why can't we just do what we did over here? 8 to the 1 point. You know, you could just fill your screen up with a bunch of 6s. Is that truly 32? I would bet it's really close, right?
Well, what about the line underneath? Is it, no, over it?
What about the line underneath?
Sometimes when I use decimals, I do 1.66 and then I put a line over it, which signifies it goes on forever.
Right. No, I know. That's what we're saying.
Oh.
That's what I'm saying. I got the line over it.
I
Okay.
am.
No, it's okay. But here's the deal. I just want you to check it, guys. What's the answer? What does it come out as? Does it come out 32 or am I way off? If I'm you, I'm going to do this. I'm going to check my answer because I don't trust these answers. Is anybody checking it? Will's going like this. It is right. Okay. I'm going to trust Will because I know it's right. But I'm gonna trust Will because I see he did it. Okay, next one, 4, base 4. This one's hard. I can't do it. Because 4 to the first is 4 and 4 to the second is what? 16, I'm not getting 18. What's 4 cubed, guys? Isn't it 64? Right? I missed it, guys. But I do know the answer's where? Between those two numbers, 2 and 3. I know it's in between 2 and 3. Okay, so now I would change the base to base 10. I don't have to put the 10 there, but I just did. Just to make you guys happy.
2.08.
Keep going. 2.08 what?
5.
Okay, so you're saying the answer is roughly 2.085. How would you guys know if she's right?
Are you doing?
Check it. Check it. How do you check it? Take your base. Raise it to her answer. Are you getting 18?
Yep.
18 what?
0.000 something.
Yeah, 18.000. I mean, that's practically 18, isn't it? We're doing it right. The bad thing about this chapter, a lot of your answers are such long decimal answers. I never trust them. I just always check them. I mean, when I was learning this stuff way back when, I always checked my answer just to make sure it was right, because the answer didn't always make sense to me. And if you don't check them, you did all that work for nothing. And it takes no time to check, because who's really checking? Did you really do that in your head? 4 to the 2.085? No. Who did it? That calculator did it. The calculator's doing it for you. It doesn't take long to type it in. Okay? All right, guys, I have 8 minutes. Okay. You have books over there. You have books hopefully in your bag. You guys could get a lot done in 8 minutes. Now, you're going to run into a snag somewhere around problem 5, 6. You'll see. I want you to ask me when you get there. What's going on? Maddie. Okay, did I get your quizzes back? And if not, you kept it for a reason, because you have questions for me. Who has a question for me on the quiz? Did anybody keep your quiz? Did you have a question? It's a no. Okay, Adrian, this is okay with you?
Yeah,
Are you sure?
I'm gonna go over 7.3.
What?
I'm gonna go through 7.3 day 1 again tonight.
Tonight?
And then I guess I can read through the notes on 7.2 and see if I understand it. Or 7.3 day 2.
Yeah. I will try and download it again tonight. I don't know why I didn't download it.
Okay.
Alright. And then you do want to take the homework quizzes, right? And that will tell you if you're good or not so good. And then the quiz, they took the quiz yesterday.
So
So you're not that far behind.
hopefully I'll take the quiz on Friday or Monday.
Yep.
So I'll let you know depending on how.
Yep, you just tell me when you're ready and let me give it to you. But quicker the better.
Yep.
Right? Okay.
I looked through the file,
You didn't find it either?
but I know I turned it in. At least I put it on that tape.
I feel like I saw it. Then somehow, some way. I went through it today.
Yeah, because you were talking to Travis, and I was gonna give it a check to her. Then I was like, wait, I can just put it on the table, so I just put it on the table.
I feel like you did too. I really do. I just couldn't find it. Why is that base two? Yeah, it is. Yeah, that's the problem I was talking about. The square root of x is really power. It's x to the.
Yeah.
Don't you remember? Check your x. When you see the square root, it can be written as x to the 1. So because it's x to the 1, the 1 half becomes the 2 half of it. You have 1 and a half, so what's that say? 1 half. Yeah, that is right. It's right, but did you know
Oh, I think
Yep, so it's 1 over 2, perfect, yeah. That's, see, those are gonna pop up on your, like that would be x to the 1. That would be x to the 1. You should have 1/5. Is that the only part of the problem? What's that 5 there? Is that the 5th thing or is that 5?
I said that.
I don't know either, that's the problem. Okay. I think you guys now probably have run into it. Number 5. Did you run into number 5 and get stumped? Yeah, no?
Wouldn't it just be log of the 1/2 x?
Log of what?
1/2 x?
1/2 x, like that?
Or no, x to the power of 1/2.
Oh, okay. Okay, do you guys remember in chapter 6, radicals, they come from fraction exponents? This little 2 is the root, it's right there. This 1 right there, that's the numerator. So John has it right. When you see radicals, change them to fractions, exponent fractions. Now what are we going to do with that fraction?
We're gonna put it in
Sorry, I didn't
front.
mean to say that. What are we going to do with that exponent?
We're gonna put it in front.
We're going to put it in front. It's going to be what?
1/2 log x.
Of x, there you go. Yes? So what if this would have been a 3? 1/3, 1/3, you get it? So you will run into that. That was not in the notes, and that's why I wanted you to get to number 5 before the bell rang. Okay, quizzes, I think they're good. Tomorrow we will be solving equations. Bring your book. You will need your book for the next 4 assignments. If you're not going to bring your book, then take a picture of your book. I don't care, but just do something. I don't want you sitting around because that's what half of you just did. Okay?